Boys and girls, everyone, read the question and try to answer it. Last question. Okay, I'll show you. Just a second, boys and girls. Let me go for the last question. Someone asked. Time required to insert an element in a stack, linked list implementation. So for a stack, insertion it can be done at beginning. Deletion also can be done at beginning. But beginning means it will take the complexity of big of 1. Right, big of 1 here. Okay. I hope it's clear, everyone. Going for the next one. Okay, now try this, everyone. Looks like everyone got the answer. Oh, few saying option 3 also. Majority says option 4, but few of you are saying option 2 and 3 also. Okay. So if the following sorting procedures, in the following sorting procedures, which one will be the slowest for a given array? Slowest means what? It takes more time. Which takes more time? For that, we need to know the complexities. Now, first thing, how do we define the efficiency of an algorithm? By its time complexity, right? By its time complexity and space complexity. So here we need to know what's the time complexity of these algorithms. Depending on that, we can define which one is slowest. So yeah, what is the time complexity of worst case complexity of quicksort? You remember that? What's the worst case complexity of quicksort? N log n. Is it right? Or n square? Quicksort is n log n, boys and girls. Remember, quicksort is n log n, not n square. Okay. There are only girls in the meeting. Is it so? Why boys are not allowed or what? Didn't get you, dear. I guess everyone is there. I see a lot of roll numbers, but what is the total count? Okay, women's campus. Okay, okay, Malaradi women's. Okay, okay, okay. Got it, got it. Sorry, my mistake. I didn't know that it's a women's campus. Okay, okay, Malaradi women's. Okay, okay. I got Malaradi, some college in Malaradi, I thought. Okay, cool. And anyways, I'm habituated with boys and girls, so manage with it. Okay. After some time, probably I'll call only girls. Okay. But right now, ignore that boys and girls. Okay, cool. So n log n is what we got. Quicksort. Next thing, what is the time complexity of Pawan sir? Yeah, sir. Just a second, sir. Sir, I hope you got the co-host access now.
Yes, yes, sure. Yes, sure.
Yeah, sir.
Go ahead, go ahead. I'll come back in the middle.
Sure, sure. Okay, sir. Okay, so fine. What is the complexity of heap sort, boys and girls? What is the complexity of heap sort? Worst case complexity of heap sort? N log n, right? N log n only. It's also n log n. And merge sort is also n log n. But what is the complexity of bubble sort? N square. Exactly. Only for bubble sort it is n square. So if you observe, very simple. N log n is bigger number or n square is bigger number? Which one will give us bigger result? N square, right? So n square will be the slowest one. Bubble sort is the slowest one. And okay. And girls, I hope you know, have you studied sorting techniques? Do you know all the sorting techniques? Okay, if you are not aware, just note down somewhere. For sure, you have to know some sorting techniques. Like I'll tell you the names of them. All these 4 which are visible right now. But I'll tell you in the order. First priority is for, the easiest ones. You have to know, it is like mandatory to know the basic things. Which are nothing but selection sort, insertion sort, bubble sort. This comes as the first priority. Okay. Note down somewhere. I hope you are carrying a notes with you. Just note down bubble sort, selection sort, insertion sort. These are considered as level 0. level 0 sorting techniques. I mean, easiest sorting techniques. And they are also worst in case of time complexities. All of those time complexities are n squares. Okay, selection, bubble, insertion, basic time complexity. We have again, but remember, whenever you are going for placements, nobody will ask you to write a program for selection sort, bubble sort, something like that. It's very, very rare. Maybe in interviews it's possible, but in general, it is never asked like that directly. They will ask applications of selection sort or applications of bubble sort, something like this. For example, I'll tell. They'll give an array for doing the bubble sort of this, for sorting this array elements using bubble sort. How many swappings are there? Understood what my question is? You have to implement bubble sort on the array given. You have to count the number of swaps occurred doing bubble sort. So that you cannot directly see. Sorting technique is very simple. Sort the elements and print it. In Python, if you want to write, you can directly write with one line also. But that's what they won't ask. Counting the number of swaps in bubble sort, or counting the number of swaps in selection sort. Or maybe after 2 iterations of bubble sort, what will be the array? After 3 iterations of selection sort, what will be the array? Like that they can ask. So for that case, you have to know the sorting techniques as detailed as possible. Okay. So try to learn these 3 sorting techniques. First thing are these 3. Enter, bubble sort, selection sort, insertion sort. Next. Next comes heap sort, sorry, quick sort, merge sort, heap sort. These are the level 2 I can consider. Quick sort, merge sort, heap sort. Okay. Then after that, we have few more called radic sort, counting sort, radic sort, counting sort, bucket sort. These are the other things we have. Okay. But at least you have to know the first 6 which I told. Clear? Girls, I hope you have noted all the names which I told. Noted? Yes. Cool. Super. Okay. So try to go through them. Maybe if you have any doubts, maybe if you want me to explain any sorting technique, I'll explain it at the end of the day, something like that. Okay. But now we'll move on for the next one. And also, girls, do one thing. Like maybe in Google you can find it out. Just create a chart like this. How you will create it? Like you will create the chart. Here you will write all the sorting techniques names. Okay. So bubble sort, selection sort, insertion sort, quick sort, all the 9 sorting techniques, something like that. Whatever the number I told. I think 9 only I told. Then here you will write worst case complexity, best case complexity, average case complexity. Okay. Like this, create a table. Worst case, best case, average case. So for every sorting technique, we'll have 3 cases, right? Best case, average case, worst case. So you have to create this table and keep it with you. So before going to an interview or something like that, you can go through this. Okay, that table. I suggest better you try to go through all the concepts once and then you create the time complexity table and then cross check it whether it is right or wrong by Googling it. Don't directly search it on Google and get download it. First, you try to recollect all the sorting techniques, you write your own answers, then cross check it with the Google searched one. Okay. So I hope it's fine. Going for the next one. Question number 125. Just a second, I'll erase these annotations. I hope you know what is hash table. I think by the number of questions you solved, for sure you should know what is hashing. In the last class, probably someone would have explained you what is hashing and all. Counting sort, cyclic sort are different here. It's in a way they are similar but not same. Yeah, sorting techniques, all the discussions, I'll do it at the end of the day today. Okay, don't worry about it. And 7. Is it fine? Index values, sir. I didn't get you. Okay, answer says majority. Okay, I got only 1 or 2 responses. What's the answer, girls? Big of 1. Okay, I got few says option as big of 1, few says big of 10. Okay, but the majority is with big of 1. Okay, cool. So it's a very simple question. How do we access? Okay, Pankaj stores n data elements in a hash table. He is able to get the best efficiency achievable by a hash table. What is the time complexity of accessing an element, any element from this hash table? How do we access elements in a hash table? Through its key, right? So directly we can write that hash key of the value of that key. Directly we'll get the value. It won't take. It is directly a unit time, right? Single big of 1 complexity. Okay. I hope you know hash table concept, everyone. Girls, have you studied hash table concept? I guess you got some early questions earlier, which are of hash table and calculating the probability of uh, storing some value in a location 2 or something like that. I remember one of the question earlier. Okay. In that, the whole concept of hashing would have explained to you. Okay, cool. So if you remember that, then we can easily answer this one. So big of 1 is the complexity for accessing any element in the hash table. Okay, directly with the help of key, we access the elements. Next, try this one. So everyone got answer? Sir, 126 option 3. Yes, yes, dear. So every element of a data structure has an address and a key associated with it. So we have address and key. When is it possible? Do we do it in address and key in linear search or binary search? No. Only thing is we use address and key values and keys in case of hash coded search only. Okay, hashing technique only we use that. Okay, cool. Hash coded search means nothing. Search the element through hashing directly. Big of 1 complexity will be the time complexity of that. Okay, next, try this one. Previous question. Okay, I'm just showing it. Previous answer is hash coded search. Hash coded search. Only key value pairs. Key value pairs are possible only in hashing. They are not. We don't have them in linear search or binary search. Okay. Key value pairs are possible only in case of hashing. In binary search, linear search, we don't have them. Okay. 125 answer also. Okay. You are not seeing answers or what? Big of 125 answer. 125 answer is big of 1. Hash table. Okay. Okay. I think I'm going a bit faster to after displaying the answer. Okay. I'll wait for some time after showing the answer. Don't worry. Next, we are at 127 right now. Just see the question and try to answer this. The order of magnitude of worst case performance of a hash coded search over n elements. Okay, they are not talking about this case or average case. They are talking about worst case. Worst case complexity means what? You have to traverse the whole hash table. That would be the case. Or maybe there can be a place where all the elements are like added through chaining concept. Maybe in the same bucket they are inserted all the elements. Okay, so those can be the worst case possibilities, right? Through chaining because of collision, maybe you would have stored all the elements in single key, or maybe other case, there may be element not found. You have to traverse the whole hash table. In that case, both cases, the traversal will be n. Simple best example would be with collision, you would have inserted elements in a single key. Like for example, I have elements like 10, 20, 30, 40, 50. And for example, and the hash code I have done, hash function I have done is mod 10. What is the hash code for 10, 20, 30, 40? If I do mod 10, what is it? 0 only. So I get collision here. So in that case, whatever the element I insert, I'll insert it the key called 0 only. So that case, I have to traverse all the elements. In that whole list, I have to traverse. In that case, we might get the concept of big of 1. Order of magnitude means time complexity. That's it. Don't worry about it's just different terminology. What is it? A worst case time complexity. That's it. Okay. Okay. I hope you got the answer. Answer is N. Clear, everyone? I hope it's clear. Going for the next one. Question number 128. See the question now. Girls, at any point of time, if any doubts, please ask. I might go a bit faster, but make sure that you are clear with it. For this, you have to know what technique it is. You should remember the sorting techniques concepts. Then only you can answer it. A sorting algorithm traverses through a list, comparing adjacent elements and switching them under certain conditions. Adjacent element comparisons will be done in which sorting technique? Adjacent element means what? Maybe next element or maybe previous one. These are the two cases possible. That means if you take any element, you will compare only with the next one or only with the previous one. Both are possible only in the case of bubble sort, right? Every current element will be, ith element will be compared with I plus one element. You remember that? We will write a concept of A of I greater than or A of I less than A of I plus one. Like this will write. If A of I is less than A of I plus one, we'll swap both of them. Am I right? If it is true, we'll swap both of this. That means one element is compared with its next element. This kind of comparison will happen only in the case of bubble sort. Okay, remember that. The question of bubble sort. Clear, everyone? So insertion sort, what is it? You will take an element and compare it with its previous elements, but not with only adjacent one. You will compare with all of them. Right? If you take one element, for example, like this, some element are there. If I choose the middlemost element, this middlemost element will be compared with all the previous elements, not only the adjacent one. And wherever it finds its place, there we will insert it. Right? That is insertion sort. Now heap sort, through a heaping concept, we use that. Heap sort, again, by using a pivot element, we'll left side, right side, we arrange the elements. But yeah, there is no adjacent comparison. Only adjacent comparison happens in bubble sort. Okay. That's why the answer is bubble sort. I hope it's clear. Going for the next question. Question number 129. Is it still people joining now? What happened, girls? Too late? Okay, fine, no problem. I hope you are listening from here. Try to people who didn't, who couldn't listen the first few questions. Don't worry, I'll share the recording with you. But others, please try to listen from now. Who have joined just now, please try to concentrate from now on. This is also sorting technique. That's why I told you have to know sorting techniques for sure. Sorting techniques are very, very important for DXC. A sorting algorithm iteratively traverses through a list to exchange the first element with any element less than it. It then repeats with a new first element. What is this sorting algorithm called as? So first you are taking first element and you are comparing that element with all the next elements. And wherever you find that the smallest element is there than that one, you'll swap with that. And then again, after that, you will select a new first element. What is that sorting technique called as? I mean, like this, we have an array. Okay. I'm just selecting this element. I'm just choosing this element. I'll compare this element with all the elements. Wherever I find the smaller than this, for example, this, let us assume this is 10 and this is 5. What will happen? I'll swap, I'll just check, compare all the elements. I found 5 which is smaller than this. So I'll make this one as 5 and I'll make this one as 10. That's all right. That means this index is sorted. Next, I'll go for next first element. Right. It repeats the new with new first element. That means I'll choose this element. Again, I'll compare this with all the next elements. And wherever I find smallest one, I'll swap with that. What is this one? We are selecting an index. Am I right? We are selecting index 1, placing the element which needs to be placed there. Again, select index 2, place the element which needs to be placed there by comparing with the remaining elements. This sorting technique is called as selection sort. Right? We are selecting the element. In insertion sort, we'll take an element and we'll insert in the previous indexes. That is insertion. Inserting in the previous indexes possible. But selection, we are selecting an index, comparing that element with all the rest of the elements, placing the element which is smaller than the current element. That is called as selection sort. Hash coded search. Hash coded search means nothing there. With the help of hash code, you will search the element. That means, for example, I have a hash table. I have hash code generated for that. There will be a hash code which will be predefined. Or maybe you can define your own hash code for storing the elements. Now, whenever I want to search for an element, I'll just write hash function of that value, hash function of that key. For example, let us assume I have something called as 123. I have to search for this. And in the array also, I have some elements like 123, 121, something like this. In the hash table, we have the elements. Now, to do hash coded search, what you will do? 123, you will generate a hash function. Maybe I'll generate a hash function called mod10. Example I'm taking. So mod10 means what? 3. So for the key called 3, there will be the value called 123 or not, we'll check. So you will write hash function of the key value, search value. Hash function of search value will give us 3. So you will check with 3 key. Do we have 123 or not? We'll check. If it is there, that's it. Basic idea is that. Okay, basic idea which I gave is that. More in detail we have to discuss, but that's the basic idea. In selection sort, we'll select the minimum element also. Not minimum element here, we'll select the first element. It's not like minimum element. Without comparison, how do you know that it's a minimum element? We cannot define. So first I'll select the first element and I'll compare with the remaining elements, choose the minimum one and swap it with that. You'll place the minimum element at the 0th index. That's what is done. Okay, select the 0th index, compare 0th index with all the next indexes possible. Wherever you find the smallest element than the 0th index one, you'll swap with that. That is selection. I hope I am clear. Selection sort. Is that clear, girls? Cool. Okay. So yeah, here what is the answer we discussed? I think we are done with the answer, right? Throw the list, exchange the first selection sort. Okay. Okay. Next one. See this one, everyone. Selection sort is the answer for the previous one. Please try this. I guess this one everyone knows. Yeah. So if you know heap sort, we can easily answer it. Yes. Super boys and girls. Super girls. So yeah. So heap sort is nothing but we use binary tree in it. Right. What about quicksort? Don't we use binary tree in quicksort also? In quicksort also we'll choose a pivot element. Left side will be smallest, right side will be greater. That also, can I consider it as a binary tree? Can I or not? Quicksort. Quicksort also, what will happen? You will choose a pivot element. You will take left side elements as lesser elements, right side elements as larger elements. Large. Do I consider it as binary tree? No. If I have to consider it, probably I can consider it as binary search tree. Okay, pivot is a root element, left side are smaller elements, right side are larger elements. We consider it as binary search tree. But actually speaking, we don't implement tree concept at all, right? But we implement recursion concept in sort. Remember that? Okay, so here the answer is heap sort. A sorting technique which uses binary tree concept such that any number in the tree is larger than all the numbers in the subtree below it is called as heap sort. In heap sort only we'll create a binary tree. The current element, the remaining elements will be larger than that. Okay. So try to, go through what if you are not aware of this heap sort, try to learn heap sort first. Then only you can understand or you can understand what I'm telling. Okay. Got it? So going for the next one, heap sort is the answer for this. Next, question number 131. So this question. Got the answer, everyone? I got multiple answers here. Why? Few says option 1, few says option 3. Oh, option 4 also I got. Why confusion in this? What's there? Average time required to perform a successful sequential search. Successful sequential search you have to perform on element in an array for A to A as 1 to N. That means what? N elements are there in the array. You have to search for a element in the sequential search. And they are asking about what is the average case time complexity. Average case means what? The element would be found at the middle position. Middlemost position, how do you calculate middlemost position in M? N elements, you have to find the middlemost position. How do you write it? N plus 1 by 2. Am I right? Yes or no, boys and girls? If you have to search till the average means what? The element would be found at the middlemost position. That means what? N plus 1 by 2 is the till half means. Okay, clear? It's not n into n plus 1 by 2 or n square n2 or anything like that. It is n plus 1 by 2. Till half of the array you have to search. Average case. Worst case will be, what is the worst case in sequential search? Worst case in sequential search. N, not n2, n it would be. Okay, there is no option for worst case. Best case, 1 to 1 colon n means 1 to n elements are there in the array. That's it. Number of elements they are telling. In an array, 1 to n is given by. That's it. N elements are there. That's it. Okay. Best case would be first element could be the search element. That will be 1. Average case would be in half of the array n plus 1 by 2. First case would be n times. Okay. All the 3 cases of linear search. Sequential search or linear search, both are same. Next. Question number 132. Let's try this. Best case would be 1 here. The first element could be the search element. If I find the element at the first index itself. What happened? Previous question not done. Okay, just showing it Vaishnavi if needed. This one. 1 to n elements sequential search. What is the average case complexity they asked? Average case is n plus 1 by 2. I hope you got it, Vaishnavi. Okay. So try, please try this one. Everyone, please try it carefully. Array is in the opposite direction. We have to sort the elements. Using selection sort, how many comparisons are happening, right? How many comparisons are happening? We have to see. Okay, for this, try to do it manually. Then you would understand that easily. See, for example, how many comparisons are needed to sort an array of length 5 if a straight selection sort is used and array is already in the opposite order. So opposite order means what? Maybe it is in descending order, we have to arrange it in ascending order. Or maybe it is in ascending order, we have to arrange it in descending order. Something like that. Okay, 5 elements, right? Let us consider. Let us take 5 elements and do it easily. Now, for example, 10, 20, 30, 40, 50 are given. 10, 20, 30, 40, 50 are given. You have to do what? Descending order sorting. For example, selection sort, descending order. In that case, what will I do? I'll select the index called 10 and I'll compare that with 20, 30, 40, 50. Which one is the largest in this? 50. So how many comparisons happen? 4 comparisons. For selection, for when I select index 1 element, I need to swap with 50. Then it will become 50, 20, 30, 40, 10. 4 comparisons happened. Okay, selection of first element is done. 4 comparisons done. Now next what? I'll start with second element. This element I have to compare with what? 30, 40, 10. Maybe I have to compare with all this. Which element is largest among these? Actually speaking, no need to compare with 10 also. But still we have to count it. But number of comparisons are what? In all the 3, which one is largest? We got 40. So you'll swap it with 40. So it will be 50, 40, 30, 20, 10. 3 comparisons done. Now, you will select the element at 30. That means you will compare 30 with 20 and 30 with 10. But you don't find any element larger than that. So, number of comparisons are 2. Next, you will select the element called 20. You will compare with it 10. How many comparisons? 1. After that, any more comparisons? No. What is the sum of this? Am I right? Understood that, girls, everyone? Yeah, I am swapping the largest element here. I am placing the largest element at the beginning. I hope you got it. Everyone understood that? So total is 10 comparisons. Okay. Answer is 10. Going for the next one. Next, see the next question. I hope it's clear, everyone. If any doubts, please ask. I hope you understood the explanation also clearly. Yes, can I go for the next one? Okay, no doubts. Going for the next one. Okay, try this, everyone. queue serves a major role in which what is the situation? Queue will serve us better, or where will queue help us a lot? Simulation of recursion, simulation of arbitrary linked list, or linked list you can consider, not a problem. Arbitrary linked list means circular linked list. Okay. Now, simulation of limited resource allocation or expression evaluation. Now tell me, recursion is simulated using what? Recursion is simulated using what? Every recursive call will be pushed, every recursive function call will be pushed into a stack, right? Same thing, expression evaluation also. Every operator will push into one stack, every operand will push into another stack, right? That is also done through stacks. And simulation of arbitrary linked list means what? Circular linked list. That we don't represent through queues. That is linked list separately only. It doesn't affect us in any ways in queues, right? It's not any queue related. Only thing which we have the answer is option 3. Okay. Expression evaluation is also done through stacks. Remember that. Simulation of limited resource allocation. Simple example, I'll tell you. Maybe you would have gone to this printout centers, right? Xerox centers or printout centers, where there will be multiple systems connected with single printer. I hope you would have seen that multiple times. There, what will happen? Resource is only the printer, single printer. But task is scheduled by, task is given by multiple systems at a time. How? Will all the printouts club and come together, or one after the other it will come? It will come one after the other. Am I right? For example, you have 3 systems. Okay, sorry. What happened? For example, I have 3 computers. Okay, C1, C2, C3. And I have one printer called P1. Okay. Now, C1, C2, C3 we have. Now I have given print from first. I have given print from C2. Okay, I have given this. Then this is first one. Then I have given print from C1. Then I have given print from C3. In which order they will get printed? First, C2 will use the resource and it will print all the printouts from C2. After that only printout from C1 will come. After that only printouts from C3 will come. Am I right? Have you seen any change in the order, anything like that? No, right? First come, first serve is done here. Resource allocation is done through first come, first serve process. And whenever the current system is using the resource, the other systems will just wait until the resource gets deallocated. Am I right, girls? I hope you remember this. Cool. Yeah, that is resource allocation. Someone asked me explain about option 2. Option 2 is very simple here. Linked list, circular linked list. That talking about circular linked list. Do we need to implement queue using linked list by using queue? Is it mandatory? No, right. I can insert at the beginning, I can delete at the beginning, I can do it through stack or through maybe through queue. It doesn't matter that we have to stick to queue only. It is not mandatory to implement circular queue using circular linked list using queues. I hope you got it. Arbitrary linked list means circular linked list. In simple words. Okay. It's not related to queues in any way. It's not mandatory that we need to relate the concept with queues. So simple answer is resource allocation. Okay, answer is option 3. What happened? Okay, simulation of limited resource allocation is done by queues. Cool. Going for the next one. Question number 134. Please try this. First thing for this, you need to know what is load factor. Do you know what is load factor? Sir, if you want to add any element in the middle, then how I can use stack? Not necessary, Pranvita. See, that's what I'm telling. We don't need to, for implementation of linked list, we don't need to think of stack or queues. We can directly implement it without this. The concept is not about stack. I was not talking about stack specifically. I was talking about in general. Maybe we can do it with stack. Maybe we can do it with linked list directly. or maybe with queue. Not sure about stack or queue. We can do it without them also. That's what the concept I was talking about. You understood that? I hope you understood. Okay, girls, first thing, you know what is a linear probing? What is load factor? Do you know what is linear probing? Linear probing means what? We solve collision problems. Whenever we get a collision, we solve it through chaining or linear probing. Linear probing means very simple. If you find an element which is getting collided, you will place that element in the next empty place possible. Okay. See, simple example I'll tell you. For example, I have a hash table like this. Okay. The hash keys are something like 0, 1, 2, 3. Like this, we have the hash keys. And for example, we already have a hash value called 10. And here also we have a hash value. Let us assume here we have a hash value called 12. And here I have something called as 13. Now, for example, you got another element that you need to store, which is 23. Okay. Now, if I consider the hash function as mod 10, what is the hash code for this? This one also I'll get 3. That means I have to store it here. Now, can you store it here? No. It gives us collision. Maybe I have to store it like a linked list. 13 is linked with 23. I have to store. That concept is called as chaining. Okay, collision problem will be avoided through chaining concept. This is chaining. But linear probing is what? It will search for the empty position. Now, after 13, do we have any empty positions? No. It will go for 10. Is it empty? No. It will go for 1. Is it empty? Yes. It will place 23 will be placed here. Okay, this is called as linear probing. Okay, this is called as linear probing. Understood, everyone? Placing the element in the next alternate possible to avoid collision. Alternate possible means whichever is empty. Okay. Now, average search time of hashing with linear probing will be less if load factor is. What should be load factor? Okay. For this, we need to know what is load factor. Also, if you have pen and paper with you or notes with you, please note down. I'll tell you what is load factor. Load factor is nothing but very simple. Number of entries by size of hash table. Number of entries by size of hash table. I mean, number of values in the hash table by total number of values possible. Linear probing, again, I'll explain. Okay, I'll do it, no problem. But first, try to note down what is load factor. Number of entries or number of values by total size of hash table. Number of values in hash table or number of entries in the hash table by total size of hash table. That's the ratio. Okay. I even shared it in the chat box also. Got it? That's the load factor. Now, average search time of hashing with linear probing will be less. When will it be less? When the load factor should be as less as possible. Okay. So load factor should be as less as possible, then only as less as possible, then only it will be better. Ratio should be less so that we can consider that it will be better. So as less means what, which is possible, as far less than 1. Ratio should be less than 1 so that it will be considered as best one, best possible. Okay, average possible or best possible. Okay, girls, someone asked me linear probing. Just listen. For linear probing, what I said is we have a hash table which has some keys and values in it. Example, I have considered the keys as 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, some elements like this. Okay. Now, all the elements are stored in the hash table. Let us assume the hash table is already filled, a bit is filled. Maybe here 10, 11, 12, 13 is not stored, 14, and 15 is not stored. Something like this is the hash table, current hash table is. Now I got one more element saying the element is 21. Now for 21, if I consider the hash function as mod 10 hash function, what is the hash code for this? For this hash code will also be 1. So what tell me, For the hash code 1, the value is already filled, right? Now, can I fill it in the same place? No. This situation is called as collision. This situation is called as collision. Okay. We can place it, but there is a process for it. We can place it through chaining or linear probing. Chaining means what? One hash code will not store only one value. It will store multiple values. If we will create a chain like this, like 21, one more element we get, again we'll chain it with this. Like this we can solve. Okay. But instead of chaining, we have one more concept called linear probing. Linear probing means we'll place the element in the next empty place possible. Okay. 21 I cannot store in the place of one hash code. So I'll skip it. Can I place it in the 2 hash code? No, that is also filled. I cannot place it. So I'll go for 3 hash code. Is it empty? Yes. I'll simply place it here. Okay. You will not depend on the only hash code. You will also check there is the next empty place possible. This placing of elements is called as linear probing. To avoid collision, we use linear probing or we use collision. Chaining concept. Linear probing means placing the element in the next alternate possible. Chaining means placing the same element in the same index by chaining it with the previous element. Like that. I hope it's clear, everyone. Okay. So if you want the search time to be low, you have load factor should be less. What is load factor? Just now I told you. Load factor is nothing but number of elements by total number of elements. That ratio should be as less as possible so that time will be less. Okay. Is far less than 1. It should be less than 1. Then we can do it easily. Okay. I hope it's clear. Going for the next one. Question number 135. Can I? Okay. So question number 135. Please try this. Girls, you know the concept of graphs. Have you ever studied graphs? And what is the concept of degree? What is graph? What is degree? If you know these things, then maybe you can answer it. You can use pen and paper and draw a graph example. Then you can maybe consider and understand that. Okay. First thing, what is graph? Graph is nothing but a non-linear data structure which are connected through edges, in which vertices will be there and edges will be there. Right. So like this, some vertices will be there. They'll be interconnected. Right. In whichever the way they want, they can be connected. There can be cycle also formed. Like this also we can have. Okay. Now let us talk about what is a degree. What is a degree? Degree means what? The number of vertices as I can visit from one vertex. Direct visit possible. So now, for example, I consider the vertex A, B, C. Now from A, how many vertices I can visit directly? How many vertices I can visit directly? Without passing through any other elements? Direct possibility is 2. Right. Okay. 2. Next, what about that is nothing but degree of A. We consider that is the degree of A. The number of elements I can visit directly from the element is considered as degree of A. Next, how many elements I can visit from B? 2. Here also I can consider the element will be degree is 2. So degree of the graph is also considered as 2. Now, number of vertices of odd degree in a graph is, we have to create something which has an odd degree. How can I create? Is here everything is even degree, right? Everything is 2, 2, 2. I have to create a graph with odd degree. Maybe I'll add one element here. Okay, I'll add one element here, D. Now, what is the degree of B? What is the degree of B? 3. Degree of B is 3. Now, what is the degree of D? Degree of D, 1. Okay. Now, in this graph, how many odd vertices are there? Sorry, odd vertices with odd degree. How many are there? 2 elements. Two vertices are with odd degree. 2 means what? Even. Right. So it is always even. You can try with anything. It will always be even. You can try with multiple examples, but that's the simple example I gave. Okay. So it is always even. Understood that? I hope it's clear, everyone. Clear, girls? Can I go for the next one? If any doubts, please ask. You can try with any graph, take your own example. Create a situation where you will have an odd degree. You will always have even number of elements because at least 2 elements should have the odd degree. Right? Okay. Going for the next one. Next. Try this. Explain again. Previous one here. 5C3. Okay, previous one, I guess. Sorry, girls, just a second. Someone needs explanation again. So let us see quickly again. First, create a graph of anything. Let us assume I am creating a graph. Graph is a nonlinear data structure. Okay, I am considering 4 elements, maybe. Okay, let us assume those are A, B, C, D. Girls who already listened it, just wait for a minute. Someone has a doubt, it seems. Let us clarify that. A, B, C, D is the elements. Now, if I connect them, what will be? I can connect like this. You can connect in your own way. Whichever you want, you can connect. Maybe I'll connect something like this. Or this one also I'll connect. Okay, like this randomly I have connected. Now let us calculate what is the degree of these nodes, all the vertices. Degree means what? Some vertices in the graph have odd number of degree. Yes, we have to count how many vertices have odd. Just see, try to understand. You can take any example and you can take random example I have taken. Now in this, how many elements have odd degree? You have to calculate that. What is the degree of A? What is the degree of A, girls? Degree of A is what? 1 or 2? 2. Degree of A is 2. Okay. What is degree of B? Degree of B is 2. Degree of D is degree of D is 3. And what about degree of C? 1. Okay. So how many elements are having odd degrees in this? 2. 2 elements, right? What are they? C and D. So what is the answer? Is always even. The number of elements in the graph, connect C to A. If I connect C to A, degree of A will also change, right? C, okay, I'll consider. Degree of C will be 2. Degree of A will be what? 3. So how many elements again? Understood that? If you keep connecting, if you keep thinking like that, you can keep increasing it. Okay, degree of A will increase, right? Understood that? Yeah, you can try with your own examples. Just think properly, we get it. Answer is always even. Okay, cool. I hope you got it. If any doubts, please ask. Okay, I hope it's clear. Going for the next one. If you remove A to D, try removing it, then some other degree will change. Now we have to consider. Again, just consider what is the degree of, okay, 1 second, I'll erase the things which are not necessary. Degree of A is 2, degree of B is 2, degree of D is 2, degree of C also 2. In this case, the number of elements are even and there are no elements which has odd degree. No, here they didn't mention directed graph, right? There is no possibility of odd degree. First, we have to create a possibility of odd degree. Then we have to count how many such elements are there, how many vertices are there. right? This example, we cannot consider it for this question. Understood, I hope? They didn't ask for directed graph. They asked for undirected. They didn't mention the directions. They just mentioned directed graph. If they mention separately, then we can consider. This example, we cannot consider for this question. Okay, they are asking us to create some vertices with odd degree. We have to create it. That is not there. Okay, cool. I hope you understood that. Clear, everyone? This graph cannot be considered for this question. Okay, going for the next one. Next. I hope you got convinced for the answer. This question, everyone. The algorithm design technique used in Quicksort. In Quicksort, what do we do? We divide the array elements into two parts, which is nothing but left array, right array, with the help of pivot element. Right? Left side of the pivot will be smaller elements, right side of the pivot will be larger elements. That means to our divide and conquer we use. Simple, right? I guess you know this concept, everyone. Quicksort, divide and conquer. Through recursion, we divide the array into two parts. Left array, right array. Even in merge sort also same thing. Divide and conquer. Right? Okay. I hope everyone is clear with it. Going for the next one. Easy question. Question number 137. Please try it. Here the question is linked lists are not suitable for. Can we implement, can we do insertion sort linked list? Yes, we can do it. Right? We can take the element, insert in its previous positions by comparing with double linked list possible. Right? Binary search, is it possible? In binary search, what do you do? You will take index called lower index, you will take higher index, you will calculate middle index, low plus high by 2. Now, in case of linked list, do we have anything called indexes at all? No, right? We don't have anything called indexes. We don't have low index, we don't have high index, we don't have middle index. It's not possible at all. Binary search means, I hope you know that binary search. You remember the concept? We take lower index, we take higher index, low plus high by 2 will do. So that is binary search is not possible. What about queue? Can we implement queue using linked list? Obviously, yes, right? We can implement. Queue using linked list means what? Insertion at one end, deletion at the other end. We can do it. So only thing which we cannot do it is binary search. Linked list is not suitable for binary search. I hope you understood that, everyone. Simple theory question. Just by imagining what they are, you can answer it. Okay, I don't understand why you got different answers. Okay, binary search we cannot implement because we have indexes. Binary search completely depends on indexes. Okay, we don't have indexing in linked list. I hope it's clear. Going for the next one. Question number 138. It's right. Okay, for this, what do we need to know? We need to know what is connected graph. Connected graph means what, girls? Can you tell me? What does connected graph means? All edges connected with each other. Yes, every element is connected with the other one. Right? They are all connected graph means what? Vertices are connected with each other. That's it. Right? Simple words I have to tell. Yes, exactly. So now if all the elements are connected, now a connected graph in which is one which what is the specialty of that? Cannot be partitioned without removing an edge. Right? How can we remove a connection? We cannot partition it without. If you want to partition, what do we do? What does it mean? Partition means what? You have to divide the graph. In that graph, you have to make two graphs or something like that. Right? Partition, divide the graph. That is possible only when you remove an edge. If everything is connected, can you make partition without removing? No, it's not possible. So connected graph means everything is connected. So in that, if you want to make partitions, you have to remove an edge. Very simple thing. Okay. By removing edge only, we can make partitions. Without that, we cannot make. Okay. Next one. Try this one. I hope it's clear, everyone. Cannot be partitioned without removing an edge. Next. Try this question. 139. Looks like everyone got it. Yeah. Stack is implemented. Stack is used for implementing recursion. In recursion only we implement stack. What about BFS? BFS means what? It's a graph traversal technique. At first search. What data structure we use in case of BFS? Exactly. We use queues there, not stacks. Okay. Cool. Next. Next one. Please try this. Answer is stack. What you got is correct. Stack is recursion. Recursion is the answer, girls. Going for the next one. Question number 140. Please try it. Which of the following is useful in traversing a given graph by breadth first search? Breadth first search means just now we discussed, right? Breadth first search uses queues. Okay. I hope you know that. Girls, do you know what is BFS? You know how to implement BFS? Breadth first search means I hope you know it. Okay. If you know it, fine. If not, we'll discuss it. Not a problem. Okay. Let's see this next question. Which of the following is useful in implementing quicksort? Girls, don't use annotations on the screen. I think I allowed. Okay. Okay. Now I disabled annotation. Not a problem. Which of the following is useful in implementing quicksort? So in quicksort, we use recursion, right? Girls, quicksort, we use recursion. Am I right? Quicksort means what? Take the pivot element, divide array into two parts, left array, right array, and again call the same quicksort for the left array and right array separately. Right? We call the function recursively. The answer is stack. Okay, not set or not list or not queue. Okay, got it? Okay, so I hope answer is stack. You got it? Not queue. Quicksort is done through stacks. Okay, going for the next one. Please try this. So yeah, which of the following abstract data types can be used to represent many-to-many relation? One element should be connected with many, and that element should also be connected with many. How is it possible? Only through graphs. In trees, what will it be? What is tree data structure actually? What is tree data structure called as? Is it many-to-many or one-to-many or anything else? Yeah. Tree is called as one-to-many. Okay. Yes. The graphs is called as many-to-many connection. Okay. Graphs is many-to-many. Tree is one-to-many. Okay, stacks and queues are unrelated to this one-to-many concept at all. They are not related with one or the other element, right? They are simply there we consider it as one-to-one, right? Stacks, queues, arrays, we consider them as one-to-one relation. Am I right? I hope you know that. One-to-one for linear data structures. Trees, it is one-to-many. Graphs, it is many-to-many. Okay. The answer is graph. I hope it's clear. Going for the next question. Question number 143. See this question. Please read the question twice, read it carefully, and then answer. Looks like I'm getting multiple answers here. Option 3 and option 2. Someone says option 3. Okay, majority is with option 3. One or two people said option 2. Okay. Let's figure out. Yeah, majority is with 3. I guess everyone read the question. Or still need more time. If anyone is still doing, make it fast. Another 30 seconds I'm giving. Okay, I hope everyone got one or the other answer. Okay, so if anyone didn't get it or anyone couldn't find the answer, listen to me carefully. Just listen carefully. Okay, we have two lists, A and B are implemented as a single linked list. So now we have two lists A and B which are single linked list. Now the address of first and last node are stored in a variable called first A, last A. Okay, for list A, we have list A first for list A, and same way we have one more list called first B, last B. Okay, let us assume this is the linked list we have. Okay, this is first linked list, and I'll consider one more linked list. This is the second linked list. Like this, any number of elements, maybe 2 elements, maybe 3 elements, or maybe 10 elements, I don't care. Here 2 elements I have taken, here I have taken 3 elements. Now, first address of first list will be stored in a variable called first A. I'll write FA. Okay. First A is a pointer. And then last address is stored as last A, LA. And here also we have addresses something like first B, last B, right? First B, last B. Like this, we have the list. Two lists we have. I hope this one is clear, everyone. And first B and last B for the list B we have. Now, given the address of a node is given in a variable node, the element stored in the node can be accessed by the statement called node data. If you want to access data, we have to access node data. And if you want to access address, you have to access it like node next. Okay, they have given both of them. Any data element will be accessed by node data. Any address will be accessed by node next. Okay. Now Pankaj wants to append list B at the end of list A. Which of the following statements should he use? So now list B should be appended at the end of list A means what? List A, last year of this one, we have to connect with this. All right, this connection we have to generate. That means what? Last year's next part, last year's pointer should store the first element's address of B. That means last year's next should store first B. Last year's next should store first B. That's all right. Understood, girls, everyone? By looking at these pictures, we can easily answer it. I hope you got it. Understood that or not? Girls, is it clear? Let me know whether it's clear or not. Yes. Okay. But this question can be asked in multiple ways. So first, I'll just change one small thing to try to answer it. Okay, you have to answer it. Now, for example, I want to append, sorry, append list A at the end of list B. What will be the answer? Please post it in the chat box. List A should be added at the end of list B. List A should be added or appended at the end of list B. In that case, what should be the answer? Okay. Last B is next is equal to first A. At the end of list B, that means list B's next part should store first element address of first list A. So first A. Cool. Super. Perfect. Okay. Great. Great, boys and girls. Great, girls, everyone. Super. Now they can ask in other way also. See, instead of telling append, they might ask us to implement something at the beginning of the list also. That also they can ask. Maybe they'll tell something like, I want to add list A in front of list B. Means what? It's same as the option 3. Am I right? Yes or no? I'll tell that I want to insert list A in front of list B. That means what? Indirectly, list A append with list B. Yes or no? Understood that? Okay. Like that also they can ask. Or they can ask in reverse also. I want to add list B in front of list A. That also they can ask. Okay. In any ways they can ask. So make sure that you are able to understand in whichever the situation it may be. Okay. I hope it's clear. So here the answer is last is next is equal to first B, because first list end point we have to add second list. Okay, I hope it's clear. Going for the next one. If any doubts, please ask. If not, we move on for the next one. I hope no doubts. Going for the next one. Okay, see the next question, everyone. What the answer for this? Which of the following sorting algorithms yield approximately the same worst case and average case running time behavior? So for this, we should know what is average case. That's why I told you to create that chart. Okay, girls, if you create that sheet, then you can easily answer it. Okay. So bubble sort, selection sort, what is the average case, worst case complexity? Sorry, worst case and average case are the same. Worst case complexity and average case complexity is always for bubble sort, it is always big of n square, right? So it is not selection sort also average case is big of n square, but they are asking about big of n log n. For which sorting techniques we have n log n complexity? Worst case and average case. Heap sort and merge sort. Okay, remember that. So heap sort, merge sort, average case and best case and worst case. Everything is n log n. Okay. Even for quick sort also it is n log n only. Radix sort, what is the average case complexity? N, right? Yeah, big of n. Okay. Clear? Got it, I guess. But for quick sort, it is n log n. Radix sort, it is n. What about tree sort? What about tree sort complexities? It is always n log n. Okay, remember that also. Tree sort is also n log n. Okay, indirectly we can consider it as heap sort also. It's similar to that. Okay, clear everyone? Binary search tree implementation can be considered as tree sort. That we can consider. And in order to traversal, we whatever the array elements given, we'll implement binary search tree. Then we print in order to traversal of the given tree, given elements. That can be considered as tree sort. Okay, Going for the next one. I hope you got the answer. Deep sort and merge sort. The worst case and average case complexity is n log n. If you create the table, you can easily understand. Don't forget it. Please make sure that you are creating the table with all the sorting techniques and all the complexities possible. Best case, worst case, average case. Okay, don't forget that, girls. Make sure that you do that. Okay, now try this one. Okay, what's the answer for this? Looks like everyone got the answer. Option 4, 31 is the answer. Yeah, okay. How do we calculate it? Just see. Complete binary tree means what? Everything should be completely filled. We have to consider. Right. For example, 5 levels they are considering. If let us see 1 second. For example, if I consider 2 levels, this is level 0, level 1. I mean 2 levels. How many number of trees are there? 3. Right. Now, if I consider 3 levels, how many trees will be there? How many nodes? Sorry, not trees. How many nodes will be there? Total number of nodes. 1, 2, 3, 4, 5, 6, 7. 7 nodes. Right. It's actually related to your binary, I mean, your binary number representation concept. Do you know binary number representation concept? Girls, do you know binary number representation concept? 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on. Like this will have. Now, if I tell you that with 3 bits, what is the maximum number you can store? Using 3 bits, what is the maximum number you can store? Using 3 bits, what is the maximum number you can store? Maximum number you can store using 3 bits. Is it 8? Are you sure? I don't think so. It is 7, right? 3 bits means what? Maybe we will write 3 ones. What is the value of 3 ones? 2 power 2 plus 2 power 1 plus 2 power 0. Which is nothing but 4 plus 2 plus 1, which is 7. So it is like if number of bits are 3, you have to calculate 2 power 3 minus 1. Right? 2 power 3 minus 1. What is 2 power 3 minus 1? 2 power 3 is 8. 8 minus 1 is 7. Same way, if 5 levels are given, that means 5 bits we have to use at most. 5 levels we have to take 5 bits is possible. 2 power 5 minus 1. What is 2 power 5? 2 power 5 is 32. 32 minus 1 is 31. Understood that? Maybe if you don't remember the formula, maybe you can directly draw the tree and check 5 levels. But unnecessary, it is 2 power n minus 1 number of nodes. Okay, remember that. The formula is 2 power n minus 1. N is the number of levels. It is same formula for the maximum number in binary number of bits. If I tell 10 bits, 2 power 10 minus 1 is the maximum number of bits you can store. Same thing, those many numbers only, the number of elements only you can store in binary tree. Binary search tree or binary tree. Okay? I hope you got it. Going for the next one. Answer is 31. Not any other answers. 2 power 5 minus 1 is the answer. 2 power 5 is 32. 32 minus 1 is 31. Got it, everyone? Girls, everyone understood that? I hope it's clear. Remember the formula. 2 power n minus 1 is the formula. Okay, next try this one. Okay, what's the question? The maximum number of nodes on level 1 or level I. It's not level 1, it is level I. Okay, sorry for that. It is level I of a binary tree. Is which of the following root is it? Root is in level 1. That's not a problem. We are considering level I at what? Maximum number of nodes you have to consider. What will that be? For example, if it is level 1, next level 2, next level 3. Okay, level 3. So in level 3, how many nodes are there? 4 nodes. That means what? What is the relation? Can you form any relation between them? If you can form 4 and 3, this is level 3. The number of elements are 4. What could be the relation we have to form? It will be what? 2 power I minus 1. That's all right. Yeah. So what is that? 2 power L minus 1 is what we have to consider. See, 2 whole power L minus 1 or 2 power L minus 1. That both difference you have to know. Okay, let us see that. For example, if I take 2 power 3 is 8. 8 minus 1 is 7. Is that what we need to consider? Or 2 power 3 minus 1. 3 minus 1 means what? 2. 2 power 2 is what? 4. So which one is the answer? Option 1. 2 whole power L minus 1. I minus 1. Level minus 1. Okay. I hope you understood that. Fourth option is not the answer because it is like 2 power L, 2 power I minus 1 separately. 2 power I minus 1 whole 2 whole power I minus 1 is the answer. Okay. I hope you understood that. Maybe you can check at level 4 also. Level 4, how many elements will be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. That means 2 power 4 minus 1. 2 power 4 minus 1 is what? 2 power 3. What is 2 power 3? 8. Got it? They are considering level from 1. Root is at level 1. That's why we are writing this. Okay. I hope it's clear, everyone. Girls, if any doubts, please ask. If not, let's move on for the next one. Okay, going for the next one. Question number 147. See that? What's the answer? Consider an array of on which bubble sort is used. Bubble sort would compare the element a of x to which of the following elements in a single iteration. Now, what do you compare in bubble sort? You will always compare with the adjacent elements, right? Adjacent element you will compare. Adjacent element means what? A of x is the element. That means a of x plus 1 will be the adjacent element. Or maybe a of x minus 1 also. Backwards, if you have to compare. If you start from last element, maybe it can be a of x minus 1. But we don't have a of x minus 1. So we will consider the answer as a of x plus 1. Okay. Answer is a of x plus 1. Clear, everyone? I hope you got it. Okay, cool. See the next one. Try this question, everyone. If someone needs previous question, why? What's following that? Okay, I'll show you that. Someone who asked previous question, just look at that. I think everyone is answering for the current question option 1, and this one is also option 1. Got it here? In bubble sort, which elements we are comparing? That's all. In bubble sort, we'll compare the element with its adjacent element. For a of x, what is the adjacent element possible? A of x plus 1. That's it. I hope you got it. Clear, dear? Someone who asked for previous question. I hope you got it. Okay. So now we'll see this one. In an implementation of linked list, each node contains data and address. Which of the following could the address field possibly contain? So what will address store? Address will always store its next element address, right? Address of next node in the sequence. Very simple thing, right? Every element will store its next element address in linked list. That's the concept of linked list, right? No need to think at all. Easy one. If you know what is linked list, then we can answer it easily. I hope it's clear, everyone. Okay, going for the next one. Try this one, everyone. Looks like everyone got the answer as option 2. Is it so? Option 2 only? Okay, let's see. Surabhi wants to implement a particular data structure using a static array. So she uses the concept of circular list to implement the data structure because this allows her efficiency use all the fields of the array. Which data structure is Surabhi implementing? Circular list she is implementing in a static array. That means what? She is implementing the concept of circular queue. Yes or no? I hope you got it. She is implementing the concept of circular queue. Okay. I hope it's clear, everyone. Static array. That too, she wants to implement the data structure because allows her to efficiently store. Circular list implementation, we will do it through circular queue. Okay. Static array means size non-modifiable array. We cannot modify the size of it. Static array means size not modifiable. Okay, fixed size. We have two types of arrays, right? Static array, dynamic array. Dynamic array means you can modify the size at any point of time. Static array means you cannot modify the size. Okay. Using malloc, realloc, pre in C language, we use dynamic arrays. Normal allocation, it is static. Okay. I hope it's clear. Okay, try this question, everyone. Which of the following is a bad implementation of Q? Bad implementation means what? Where we have more restrictions. In which case we have more restrictions? Bad implementation means we have more restrictions. We don't have freedom of implementing. Girls, think carefully. Bad implementation means the freedom of implementing is complex, or there is no freedom of implementing the queue properly. Which case it is? In which case we don't have freedom? Option 4, right? Static array. Size is fixed. Linear static array. Implementation of queue will be the worst possible because we cannot modify the size. We cannot implement more elements. It is like fixed size. But in case of circular linked list, we can add any number of elements. That is efficient one. Doubly linked list also efficient. Doubly linked list, circular list means circular linked list, circular queue implementation. That is good. Right? It's the best implementation possible. Doubly linked list also possible because both side direction traversal is allowed. So we have more freedom. We have traverse forward, we have traverse backward. We can implement in whichever the direction we want the queue. Right? Single linked list also it's okay, not first. Maybe we can go with insertion at the end, deletion at the beginning. But in case of linear static array, size is fixed. We can never modify the elements or we cannot increase the size of the queue. So that's the worst possible. Okay, remember that. For anything, array is the worst possible implementation. Okay, static array is the worst possible implementation. Remember that, girls. I hope it's clear. Not only for queues, for stacks also worst possible is linear static array. Okay, next question. Please try this. What happened here? But there we choose Q as the answer. Sir, in previous questions, same condition. No, sir. Like it can be implemented by static array. No, they are asking about worst possibility of implementation. I think the two questions which making some confusion. Girls, just wait. I'll just go back to the previous two questions and I'll come back. Here the question is, Surabhi wants to implement a linear static array. How can we implement this circular list? Circular list implementation of data structure. So can you implement circular list through stack? Not possible, right? You cannot insert in bidirectional. It's a unidirectional. Binarity is not at all related to static arrays, right? It's completely different concept. It's not related to circular list concept in any ways. Circular list is possible only through implementation of circular queue, right? Am I right, girls? That's why we choose queue and static array here. Don't relate static and array and queue here. Okay, it's a different concept completely. Here they are asking what is the worst possible implementation in all this. We can actually implement queue using all of them. We can implement using circular list, we can use double linked list, we can use single, and we can use linear array also. In this, which one is worst? In which we have more restrictions. We have one of the worst restriction called size restriction in linear arrays, linear static array. So size is restricted. That's why we consider that as worst possible one, not the best one, right? I hope you got it. Why the answer is linear static array now. Now see question number 151. I think 151 people have answered the question already. Which of the following statement is true about doubly linked list? Yeah, people have given answer as 1 and 4. No, I didn't get the answers. Only 1% get the answer. Okay. Which of the following statements are true about doubly linked list? It must contain a header node. It may be either linear or circular. It must contain a header node. It will occupy same memory space as that of single linked list, both having same number of nodes. No, this is absolutely wrong, right? Because memory will be more for double linked list, single linked list it will be less. So it either this one can be the answer or option 2 can be the answer. Now none of this may or may not be. Let us see first one. It may be either linear or circular. So double linked list, can you implement this linear circular linked list? Yes, we can implement. Can I implement circular? Last element connected with the first one? Yes, possible. So that can be the answer. Now what about second option? It must contain header node. Header node means what? Element which is pointing to the first node. Am I right? Yes or no, guys? A pointer which is pointed to the first element is called as header node. That means what? That also must be there. So answer is what? Both 1 and 2 here. Okay. Answer is both 1 and 2. These kind of questions are checkbox questions, we call it as. Okay. Maybe the answer is marked as only one, but answer is both 1 and 2. Okay. Both 1 and 2 you have to choose. See, if it is checkbox question, we'll choose both 1 and 2. If it is option wise, you choose 1 or you choose 2, both will be correct. Okay, any one you can answer, both will be correct. Got it, everyone? If it is checkbox question, make sure that you try to select multiple options. If it is getting selected, that means answer is multiple answer. Very rarely you will get these kind of questions, but just check it while answering. So for any question in DXC, make sure that you are checking the other options also. Just don't simply answer it that, okay, you got the answer, that it is not the answer. Try to check why not other options also. Okay. I hope you got it what I said. Here the answer is both 1 and 2. If it is checkbox, both 1 and 2. If it is only option wise, you can choose one or you can choose both. Both will work. Okay. Cool. Going for the next one. Try this question. Question number 152. Which of the following data structure may give overflow error even though the current number of elements in it is less than its size? When is it possible? What's the answer, girls? I got only few answers. Okay, option 3 is what you said. That too only 2 or 3 people said. What about others? What's the answer, girls? Overflow error even if the number of elements are not completely full. Okay, girls, first thing, tell me, if the number of elements are less than the number of size, less than the size of it, will it give a overflow in stack? Right? What is stack? We implement only through one directional, unidirectional. Only when the number of elements are number of size as same as the size of the stack, then only will get overflow. If not, will not get. Stack will never be the answer. Okay, for sure, stack is not the answer. Then we have to think option 1 or option 2. So let us talk about option 1. Q implemented in a linear array. So when you implement Q using linear array, what will happen? Okay, let's see. For example, I'll assume that this is a linear array Q which I have. Now I'll insert maybe 4 elements. Let us assume size of the Q is 5 or okay 5. 1, 2, 3, 4, 5. I'll insert 2 elements in the Q like 2, 5 like this we have. Okay. Now I'll delete these 2 elements. I'll delete these two elements. Okay. Now, maybe I can delete it. Done. I'll insert three more elements. 7, 8, 9. Now, how many number of elements are there in this queue? After deleting 2 and 5, 3 elements are there. But in a linear array, can you insert elements in the beginning again? No. If it is circularly connected array, then maybe we can insert elements again here. But it is not circularly connected. Can you use these two locations again? No, we cannot use it. But can you insert more elements? No. Understood what I'm saying? Girls, in a linear array, number of elements, I have inserted 5 elements. After that, I deleted 2 elements. Okay, first 2 elements I deleted. Now the current number of elements in the queue are 3. Is it same as the size of the array? What size of the array? 5. But the number of elements are only 3. It is lesser. But can you insert more elements? No, it's not allowed. If you try to insert elements, it will give error. Stack also same thing, right, dear? Stack also will be similar thing. See, for example, you have a stack. Like this, I have a stack. I'll insert the element here. I'll insert the element here. I'll insert the element here. It is unidirectional. Okay, 5 elements are there. I'll insert 5 of them. Okay, all the 5 are inserted. 1, 2, 3, 4, 5 are inserted. Okay. Now, from where you will delete the element in the stack? From the place where we have inserted. We inserted at 10, that means I'll delete 5 only. Now, can you insert element again? Yes, we can insert again. Here only will insert, here only will delete. Am I right? Here only will insert, here only will delete. But in case of Q, what should we do? If I insert at end, I have to insert at the beginning. Is it possible to insert at the beginning? No. Got it? Q is a bidirectional, stack is a unidirectional. In unidirectional data structure, we deleted that position, there only we insert. But in Q data structure, we inserted one end, deleted the other end. Understood that? So answer is what? Q implemented in a linear array. I hope you got it. Girls, is it clear? Or any doubts? Please ask if any doubts. Clear? Super. Okay. Okay. Going for the next one. Question number 153. Please try it. What happened, girls? No answers for this? Number of possible ordered trees with 3 nodes ABC. How many ordered trees we can form? First thing, do you know what is ordered tree? Ordered tree means if you get one order, you should only consider one order. The other orders, at a time, you have to consider only one order possible. If you consider ABC in the left skew tree, you cannot consider right skew tree. Okay, only one you have to consider. See, for example, if I have ABC like this, okay, this can be considered as one tree. Now, if you consider this one, you should not consider this one. ABC cannot be considered. Right skew tree cannot be considered. This is not allowed. Only this in between these two, you have to consider only one. Like that, how many trees are possible? Understood what I said? If you take left skewed one, you should not take right skewed one. You can interchange the elements, that is allowed. Complete order, simply order changing is not allowed. Simply side changing is not allowed. Okay, looks like no one knows this answer. Okay, just see here, I'll tell you. It's very simple. Example. Actually, I have two possibilities. I mean, two ways of doing it. Okay, just here, two ways of doing it I have. First thing is a tree with two children. Okay, a tree with two children in a simple way. Okay, two children possible trees are what? A, B, C. This is one. Or maybe I can consider this one also. Swapping is allowed. Okay, A, C, B. I can consider these two. Okay. In the same way, I can consider B, AC and B, CA. Can I? Got it, girls? I can consider these two. Next, in the same way, I can consider C as the root node, and I can consider CAB, C. One second. I can consider CAB and CBA. Okay, these two I can consider. So total how many? 6. For a node with two children, each node which has two children, in that case we consider total possibilities are 6. But okay, same way we can implement other possibility also. Just see, I'll just erase all the three completely. Now, first we got 6. After that, I can implement like this also. A, B, C, a left skewed tree, but I cannot consider right skewed tree because they are talking only about ordered trees. Okay. Now, but I can consider ACB. I can consider this. ACB is possible. So like this, two are possible. Same way with B as parent, I can take BAC, BCA. Right? BAC, BAC, BCA. I can consider this. Same way I can consider CAB, CBA. CBA. I cannot consider right skewed trees. Okay, left skewed trees I am considering, so I should not consider right skewed one. So these are the possibilities. Total how many? 6 plus 6, 12. Okay, these are called as ordered trees for three nodes in it. Okay, girls, if needed, just note down the trees also. In your notes, is there any formula like that? I don't think so. Directly any formula? Not sure, dear. We'll check it and I'll let you know if anything is there. I'll let you know in the afternoon session. If anything. As of my knowledge, nothing like that. Directly we cannot possible. That's what. If there are many nodes, how do we define? That's what I'm thinking. Yeah. I'll tell you that. I'll find out what's the formula for it and we'll let you know. No. We should not consider right skewed trees, dear. That's what I told. We have to consider only ordered trees. We should not consider the same tree with a different order. See, ABC, we can consider A here, B here, C here. Same thing I can consider is ACB. Okay, this is one tree. Like this, with A as parent, you can make 2 trees. With B as parent, how many you can make? 2 more. With C as parent, you can make 2 more. Okay, these are 6 possibilities. A node with 2 children. Same way, you can make a node with 1 child saying that A, B, C like this. left skewed tree. If you consider left skewed, you should not consider right skewed. Okay, that is called ordered trees. Yeah. I understood that. I'll tell you that, no problem. Mostly they won't give bigger numbers, they'll give a smaller number only. But yeah, don't worry, I'll let you know the formula if anything is there like that. ABC we have to consider ACB. Okay. These are two with A as parent. Same way with B as parent, we get another two. C as parent, we get another two. So total 6 here, 6 here. Total 12 possibilities. Okay, if they are telling unordered trees, we don't worry about the order. Then we'll consider another 6 more. Okay. A is a root and B is left child of A and C. Okay, you are telling this one, A, B, C. Is this what you are telling? Something like this? A's right child is B, B's right child is left child is C. No, this is also not considered. Only order change, right? That also we should not consider. We should not consider just by changing the side of the node. If two nodes are getting interchanged, then it is possible. If only one node interchanging direction is not allowed. Okay, understood what I'm saying? If you traverse it, you should not get the same order. See, here I'll get ABC only. If I get this one also, ABC only I'll get. That should not be considered. If they ask unordered tree, it will be too many. Many number of nodes, we cannot count it. For we can consider. No, if you consider left, we cannot consider right here. That's what I'm telling. What I'm telling is, if you consider one node as a right node, if there is no left node, you cannot consider it as a left node. Only if it is there, then you can swap both of them. Understood what I'm telling? Just see. Simple thing what I'm telling is, try to understand this. Girls, if I have a node like this, here it is A, here it is B, here it is C. I can interchange these two and consider it as another tree. That is allowed. But for example, you have A, B, that's all. Only two nodes are there. You can consider only one order. For this, there are no multiple orders possible. Only one order is possible. This way. Or you can consider B as the root node, A as the child node. That's all. No other orders are allowed. Understood? You cannot consider A's right child as B. This is not allowed. B's right child as A, not allowed. Okay, because if you write the order, if you write the traversal, you'll get the same traversal, right? Here we'll get BA, here also we'll get BA. Here I'll get AB, here also I'll get AB. When the order is same, it's not allowed. Understood that? I hope now it's clear. If you try to print the elements of the elements in any order, you should not get the same order. Okay, same order output should not be possible. In that case, if you try to write it, order differentiation is possible only for 6 trees like that. Other than that, whatever you write, you get the same order. That's why the answer is 6, 6, 12. 6 for 2, A for 2 children, 1 children it is, 1 subchild it is 6. So total is 12. I hope it's clear now. Girls understood that? Okay, cool. Going for the next one. Question number 154. Please try it. Girls, try to understand one thing here. They are not asking about time complexity. They are asking about less number of swappings. In which sorting technique, less number of swappings will happen. If number of swappings done is the only consideration. Think carefully about the sorting techniques and answer. And girls, one more thing, try to understand swapping is different, shifting is different. I hope you know that. Swapping is different, shifting is different. Swapping means it happens between two elements. One will get into another position, other will get into that position. If I have A comma B, that will become B comma A. That is swapping. Okay, getting multiple answers here. Some says 2, some says 4, some says too many answers I got. Okay, just see, try to understand what is bubble sort. First element will be compared with next element. If the element is lesser, you will keep swapping it. So there can be possibility of swapping with all the elements, right? Like every element, it can be swapped, possible, right? So that is more number of swappings happen in bubble sort. Even in selection sort also, what will happen? You select the index, compare with the remaining elements. Wherever you find a smaller element, you will swap with it. Yes or no? Swappings are done in selection sort also. What about insertion sort? Insertion sort, what will you do? You will take an element, you will compare that with the previous elements, and you won't do any swapping there. What you do? You will shift the elements forward. Right? See, insertion sort, try to remember what is insertion sort, girls. For example, if I consider the element something like this, I have some elements like 10, 20, 30, 40, and 5. I have some elements like this. Now, what you'll do, if you have to sort it, I'll insert 10, I'll compare with previous elements. Is there any swapping happening? No. 20 will be compared with 10, not possible. When you compare 5 with 40, 5 with the previous elements, what you will do? You will compare with all possibilities. You will compare with all of them. But swapping will happen anything? No. Swapping will not happen at all. What will happen? 5 will get inserted at the beginning. But before inserting 5, 40 will come here. That is shifting. 30 will come here. 20 will come here. 10 will come here. Now 5 will be inserted at the 0th index. Are you swapping elements or are you shifting? The current element, you are the remaining elements which is not in the order, you are shifting them. But are you swapping them? No. Right. They are asking about number of swaps. In insertion sort, quick sort, bubble sort, selection sort. Sorry, in bubble sort, selection sort, quick sort, you keep comparing two elements and do swapping between every two elements possible. But in case of insertion sort, you don't swap. You will insert the elements. Okay. So shifting happens. So here the answer is insertion sort. Because no swaps, shifting happens. Okay. There is no swapping, shifting happens. Clear? Even in quick sort also, we'll swap the elements. Left array will be swapped with right array elements or something like that. But you will not shift. Only swapping is not there in insertion sort. Here I hope understood that everyone. Because of shifting, we are considering insertion sort as the answer. Okay, cool. So the next one, answer is insertion sort. Try this one. Just imagine the real-time scenario and try to answer it. Try to imagine the real-time scenario and answer it. It's not related to time complexity or anything like that. Okay, listen here, everyone. Girls. As part of the maintenance work, you are interested with the work of rearranging the library books in a shelf in a proper order at the end of each day. The ideal choice will be what? See, what will happen in a library? Someone will pick up the books, read them, and place it in the table or place it somewhere else. Right? Maybe in the table or may not be in the shelf. What you will do? You will choose the book which is not in the order, and you will insert that book in its position. Right? By comparing with the books in the shelf. Yes or no, girls? So what you are doing? You are inserting the book. Am I right? You will move the books towards the left side or right side and insert in between them. Yes or no? Try to imagine the real-time scenario. You will not do bubble sort or you will not do insertion sort. Every book will not be compared with everything, right? You will check which order. One book you will hold in your hands and you will check where that has to be placed. Directly you will place there by moving left side or right side the existing books. So it is like inserting the book into its position. That is insertion sort. Okay, don't imagine complexities or anything like that. You don't have order or anything like that, right? It's not numbers. Numbers means maybe we can think of complexity or anything like that. But it's books. You will physical entities. Those are insertion sort is best one. I hope you understood my explanation. Answer is insertion sort. What happened, girls? Previous one. Okay, very simple thing. Try to understand. Insert books arrangement. So in a book, a library generally assume what happens in library. There will be books in the shelf. Someone will come, pick up some books and place those books, red books in the table or somewhere like that. And maybe they'll submit in the other department. See, books are like this. I have book numbers, maybe 1, 2, 3, 4, like this. I have book numbers 1, 2, 3, 4, 5. Like this, I have books. Now, someone will pick up the book 3 and read it and place it at the table. Now, my duty is what? Placing this book at its position. What will I do? Should I do bubble sort or selection sort or heap sort or anything like that? No. I'll compare with the books and I'll place it at its position. It's like insertion sort, choosing an element and placing in its position. It's called as what? Insertion sort. Am I clear? Choosing an element, taking an element and placing in its position. It's called as insertion sort. In a library, insertion sort happens. Okay. You will not do swapping and all in libraries, right? You will not swap the books which are already existing. You will place the book which is used in its position. That is insertion sort. Okay. Okay. Try this one, everyone. Hello. Am I audible, girls? Okay, okay. Thank you. No problem. That's fine. Okay. See this question. I think this question, was it done earlier or not? I guess this is a repeated question. Hash table can store maximum 10 records. Currently, there are records in locations. Is it done or not for you? Was it done earlier? No? Okay. Just try if you can. Do you remember linear probing concept? If you remember the concept which I told, then you can answer this. Try it if you can. What's the answer, girls? Anyone got it? Important question. Try to understand. If you remember the concept of linear probing, then we can answer it. Okay. Just for understanding, I'll take one empty slide and I'll tell you. 1 second, girls. Answer is 0.6, but we need to understand how. Okay. Just see here. 2, someone said 2. No, not 0.1. Answer is 0.6, but just listen how. Okay. Now, how many records are there in the table? How many hash table can store? Maximum records is 10. Okay. 10 number of records. I'll write them. Okay. I'll create a hash table with 10 elements in it. Okay, this is 1, 2, 3. And I think the values are also given. Let me go for the previous slide and just see what are the values we have. Okay, 1 to 10 numbers only. So I'll write the numbers also. No problem. 1 second. This is 1, 2, 3, then 4, 5, 6, 7, 8, and 9. 10 record means 1 to 9 only possible, right? Total number of records they are telling us. Oh, 1 to 10 numbers, right? Okay. 10 also I have to consider. Sorry. 0 to 9 I have to consider, or 1 to 10. Okay. Like this, I am considering the hash table. Now, what are the elements which are already stored in the hash table? Let us see that. Can store maximum 10 records. Currently, there are records in these locations. 1, 3, 4, 7, 8, 9, 10. There are there. Okay. So maybe I can store them. 1 second. 1, 3, 4, 7. Let me write them. I'll just fill them. 1 is filled. 3 is filled. 4 is filled. 1, 3, 4, and then 7, 8, 9, 10. Okay. 7, 8, 9, 10. 7, 8, 9, 10. 7, 8, 9, 10. These are already filled. Now, what is the question they are asking about? They are asking the probability of a new record going into location 2 with a hash function resolving the collisions by linear probing is. So, by doing linear probing, if you have the element, place the element at position 2, what will be this? What is the possibility of the probability? Now, tell me. Now, doing linear probing, if I have to insert elements, or suppose if I got another 1, for example, I got another element where I have to place it in 1. Will it be placed in 2? Yes or no? Here there is, if for example, if I take the element where I have to place it in the hash table of 1, what will happen? Collision happens. Collision happen means I have to place it in the next possible empty place through linear probing. So I can place it at 2. So that is one possibility. Right? That is one possibility. Okay, next. If I get directly to the element which I get the code, hash code has 2 directly. It will directly get placed in 2 because 2 is empty. Possible? Yes. Now, for example, I get some value which should be placed at 3. What will happen? 3, it's collision. It will not be placed. It will try to place it in 4. It's not possible. It will get placed in 5. Will it get to 2? No, it will not come to 2. Because of linear probing, we'll check the next possible empty place. That means it will get placed at 5 only. So I cannot consider 3. So next, 4. If I take element which I have to place at 4, what will happen? 4 it will not get placed. At 5 it will directly get placed. So 4 is also not possible. Next, what about 5? If I get element that I need to store at 5, directly it can be stored. Right? No need to go for linear probing, or there is no collision at all. So this also cannot be the answer. Next, 6. Can I place it? Yes, directly I can place it. So I cannot consider it for 2. It will not go to 2. Next, what about 7? If I get an element that I need to place at 7, it will check. Can I place it at 7? No. Can I place it at 8? No. Can I place it at 9? No. Can I place it at 10? No. Can I place it at 1? No. Can I place it at 2? Yes. So if you get something that needs to be placed at 7, that will enter into 2 because of linear probing. So 7 can be the answer. Okay. No, I'm talking about all. They are asking about probability here. Probability of 2 element getting placed in 2. We have to check all the possibilities, right? I can press. Directly placing a 2 is one possibility. Okay. Directly placing a 2 is one possibility. See, for example, I have an element that I need to store something like 21. 21 means what? If I do mod 10, I have to place it at 1, right? I have to place it at 1. Will it get into 1? Because of collision, it will not go. It will go to 2. Okay, girls, just listen carefully. Try to understand this. I'll explain again. It's nothing is there. Very simple thing. See here. See, first, these are the elements which are filled. I hope you understood that, everyone. Oh, something got erased. Let me draw them back. This is the table we have. Only 2, 5, 6 are empty. 2, 5, 6 are empty. Am I right? Other than that, everything else is filled. If I'm not wrong. Right? Okay. Now see, for example, let us assume we are doing a hash function called mod10 hash function. Easy way to do is mod10. That's why I'm taking mod10. Okay. For example, I got an element called 21. I got an element called 21. For 21, what is the hash code of it? 1. That means what? You have to place it at 1. Now, do we have 1 empty? No. Collision happens. To avoid collision, what will I do? I'll apply linear probing. Linear probing means I'll place it in the next empty possible place. What is that? At 2 I'll place. So that means what? If I get 21, I can place it at 2. It might get placed at 2. Because of linear probing, it will get placed at 2 for sure. So that is one possibility. First possibility is maybe 21. What if I get directly 22? 22, what is the hash code for it? 2 only. Now 2 is empty? Yes. That is also one possibility. This is second possibility. Okay. Now, for example, I get 23. 23 is the element I need to place. What is the hash code of it? 3. That means I have to place it at 3. Okay. Is it possible to place it 3? No, because it is already filled. I have to take the alternate one. What is the alternate one? Maybe 4. But can I place it at 4? No, because it is also already filled. So what will I do? I'll check the next possible one. What is the next one? 5. Can I place it at 5? Can I place 23 at 5 because of linear probing? Yes or no? Girls, what do you say? Yes or no? Can I place it at 5 because of linear probing? Yes. That means what? If I get 23, I'll not be able to get into 2. It will get into 5, not into 2. That means 23 is not possible. Till now, we got only 2 possibilities. Okay. Next possibility I might take, the number is 24. If I take 24, what will happen? It will check with 4. Not possible. It will check with 5. Possible. Done. Will it go to 2? No. So I cannot consider 4's possibility also. Next, I'll consider 25. If I take 25, what will happen? 5 is already empty. So I can place it here directly. So 5 is also, it will not let us go to 2. Next, what about 6? 26 if I get. I have to store it at 6. 6 is empty. I can place it directly here itself. It will not go to 2. So 26 is not possible. Are you able to understand me now? Girls, are you following me? I hope everyone is able to understand. Till now, is it clear? Yes? Okay, cool. Now, for example, I got 27. If I get 27, what will happen? I have to place it at 7. Is it empty? No. I'll check with 8, not empty. I'll check with 9, not empty. I'll check with 10, not empty. I'll check with 1. Go back to the beginning. I'll check with 1, not empty. I'll check with 2, empty. I can place it. That means 27 may be possible. That is third option. Third possibility. Okay, third possibility. Next, what is 28? For 28, what will happen? It will check with 8, not possible. Check with 9, not possible. 10, not possible. 1, not possible. Goes to 2. That means 28 can also be the possible one. So, fourth possibility. 29, that is also possible because 29 not possible. 10 not possible. It goes back to 1, not possible. Goes to 2. So, 29 is also possible. Fifth possibility. So 30, for example, I got something which is ending with 0. What will happen? I'll try to place it here. I'll go back. It will get placed at 1. No. It will get placed at 2. Yes. So this is sixth possibility. Out of 10, how many possibilities are there? 6. So probability means what? Total number of possibilities. Number of possibilities by total number of values. Total number of locations are 10. 6 by 10. What is 6 by 10? 0.6. Understood that, girls? Is it clear? 6 possibilities are there. 6 by 10 is the probability. 25, 26, very simple here. 25, if I get 25, I took the code with 5. Do we have any value at 5? No. I can place it here itself directly. It will not go to 2 or it will not go to 2. It will not redirect to 2. Understood that? If I get something called 25, that the value at 5 is empty already. So I can place it here itself. Will it go to 6 or will it go to next positions? No. There is no collision at all. Understood that? For 25, 26, there is no collision. So there only they will get placed. If collision happens, we'll check the next alternate. If there is no collision, directly we'll place there. Okay. Understood, I hope. Okay. So the answer is what? 0.6. Okay. Number of possibilities by total number of positions. Probability. Okay. I hope it's clear. Okay. Fine, girls. You can take a lunch break. I guess your lunch break is from 12:30 to 1:15.
Yeah,
if I'm not wrong.
Yeah. Hello,
Yes, sir.
Shiva.
Yes, sir.
So I want to say something just a minute. I think
Yes.
as regularly they are giving 12:30 to 1:30 as per your convenience. There is no specific time format. If it will be 1 to 2 also, there is no problem. But you can take your own decision. There is no issue for this.
Okay, sir.
Maybe 1 hour time we are moving for lunch. Maybe 12:30 to 1:30 or 1:30. I think if you started with 10, 2.5 hours only over. And again, if it is start from 12, 1:30, then 4 is last time. As per your convenience, you can.
We'll go with that, sir. That's better option. Anyways, I said let's take the break. No problem. Anyways,
Okay,
we
no
have done a
problem.
lot of questions.
12:30 to 1:30, you are giving a break for the lunch.
Yes, sir.
Okay.
Yes, sir.
Students, please listen. So today, just now I have received a link for today's assessment test, which is starts at 7 o'clock and end that link at 8 p.m. Only 1 hour. The link will be opened. With that link, you have to register and start your test. So there is no previous links, previous users, previous logins, previous credentials are not using here. Immediately you have to register and complete the test today. That test will be scheduled at 7 to 8. And one more thing I want to share to you here. This training will continue even Monday, Tuesday also in virtual mode. Monday, Tuesday or Wednesday, we will communicate to you. You must be virtually, you have to attend wherever you are. You are in a home or a hostel or anywhere. Wherever you are, you must and should attend. The count is almost reducing from 900 to 700 now. So what is the reason on that also? I think this is not a way to ask you always. You inform to your friends. Maybe some people may left from this meeting due to some reasons, maybe a network reason or maybe a bandwidth reason or something. I'm not able to say, but you prepare yourself, you fix yourself to must and should be attend between 10 to 4 for these online assessment training, this virtual training, what we are planned. So the questions, whatever you are covering in this training is each and every question have its own importance. Each and every question have its own importance. So that don't skip any question. That only I'm saying. Previously that count is 800 plus. Now the count is 720.